Another thing you might think about is a database administrator. Database administrator is somebody that is basically going to be in charge of maintaining a set of databases, quite often more than one, but a set of databases, and mostly you're looking at query performance, some development of queries, and backups, and test databases, reliability, and capacity planning. Capacity planning is where you're looking at over time the growth of the database and how you're planning for additional storage or changes to the database and version upgrades. That's an important thing. So basically you're not that much into development, although you do have some development of queries. Mostly, I'd say 90% of your work is not development. You are an administrator maintaining a database. And certainly these days, this kind of stuff, this is really kind of a DevOps automation thing, that you would like to be able to take a lot of these things and make certain that you can do the backups, that they're happening automatically, that you've got some sort of a dashboard either from some application that you're using or something that notifies you if the backups didn't work, and if they did. That's pretty critical. You're responsible for maintaining the availability of the database. And, you know, this quite often can be sometimes a trying thing to maintain availability. I mean, something goes wrong. The biggest reason for people to have loss of data isn't bad hardware. It's because some developer went in and did something wrong and deleted a huge chunk of data or dropped a table, and now you've got to restore this. Maybe you have to, depending on how your backup system works, know how to restore just a table as opposed to restoring an entire database. Know what the relationships are between your tables, that if they deleted this data, that means it cascaded over to this other stuff, and how you're going to recover this. Sometimes in recovery, and you should be doing recoveries on a regular basis, sometimes in recovery you want to restore an entire copy of the database, pick the pieces out, and then copy it back in. There are different kinds of scenarios depending on your data. But database administrator, I did not start out being a database administrator, although I have worked at one. I started out, when I looked at this, as being a developer, and I wanted to build a product company, because since I was a developer in my own consulting company, I wanted to get out of consulting and build a product. And one of those things was automating a bunch of things that DBAs do, so that, you know, you had track of backups and it was automatically notified. You had a way to quickly build test databases. You had capacity planning built in. You had some stuff about query performance built into the product. So a bunch of these things were automated. And I went out and said, okay, what am I going to do for this? I'm going to read everything. I'm going to get a job in this. I'm going to learn how to be a database administrator. And then I'm going to build a product. So this is something that you can learn. I would recommend, if you're going to do a DBA, that you look at things like either Microsoft or Oracle certification. Because that will go a long ways in terms of getting a job as a DBA. Now, DBAs, by personality, I'd say have to be they're like accountants. Okay, your job is not to make things new. Your job is to make certain that that database or your set of databases never break. So it's not a risk-taking job. It's a risk-adverse job of, let's make certain we get this done right and we don't break anything. That's what you're after all the time. Whereas a developer, you know, it's like move fast and break things so we can get things done and get things built and move on to new things. So it's a different sort of a person generally that does a database administration. Before I get off the subject of database administrator, I would guarantee that you are on call if you're a DBA. If that doesn't suit you, don't do that job. Because sooner or later, things will break in the middle of the night, and yes, you will be working through the night on some system. I've actually had calls as a database administrator where I was having hardware and software problems and had HP on one phone line talking to them about this, and Oracle, and they would transfer us around the world to their call centers as they were working with us, and I have had 24-hour phone calls to support as we're trying to get a system back up and working. So yeah, that can be sometimes kind of ugly. But on the other hand, database administrator, the pay tends to be pretty good. So it is a very viable thing. Data modeling. There aren't very many jobs doing this. But the flip side to this is data modelers tend to make the big bucks. Every once in a while on Y Combinator, I see a job go by for data modeling, and I go, oh my goodness, they're offering $250,000 for this. So, an experienced data modeler makes a gob, and if that is your thing, to be doing something that is basically between the business side and the development side, to be modeling data and figuring out how to represent data itself, this is a very viable thing. It is not necessarily that much of a development job quite often as it is a business analysis job. As in, we'd like to build this product. What are the pieces? How are we going to break down the pieces? Where are we going to find all the data? How are we going to make certain that this is accurate for what we're doing for the data? They come around once in a while. I've never had a job doing it. We're talking about entity relationship models where, you've got one table that relates to maybe some other table that relates to, this is an M-to-N relationship, to some other table over here, and how these work together. To give you some idea of the kind of scale of these things, we're talking about models that have 10,000 tables in them is pretty common, sometimes 40,000 tables. I worked on a project for the Defense Department quite a few years ago, and it was for modeling for battlefield tactical planning, and we had 16,000 tables in it. And, that's... And they had a full-time data modeler just for that project, just in that one particular thing they were working with. I worked for one that was a GIS system for people like utilities, and it had 8,000 tables just for modeling their transmission lines, their utilities. So these kind of numbers for tables are not that uncommon. So these are not little tiny models with, 3 tables. These are big, complex things. Another one that tends to pay pretty well, but you need statistics for this, is a data research scientist. And this is a hot one these days. A data scientist. And you need query knowledge to query the database, so you need SQL knowledge. Quite often very complex queries to pull statistical information out of the data or to mine into the data and pull out new information. And this kind of a thing makes a lot of money because these people don't just need computer and database skills, they also need statistics. So if you're going to do that, you're going to need to take statistics classes and be very familiar with how you're going to turn this raw data inside the database into useful information that can actually result in changes in a business. And the best example I have seen of this is Victoria's Secret some years ago hired a data scientist, gave them their data and started poking in, and they found out that there were regional differences in the sizes of women's undergarments. And consequently, one of their biggest expenses is things that don't sell, that they then have to sell as discount over time. And if they could just change their inventory to more match with what their customers actually are in different locations, they save something like 15% on their overall business expenses because of one set of queries that this person put together in about 2 weeks. And that kind of stuff, that kind of results means lots of money for the business, and that translates into high pay for the person doing the work. And those are not that uncommon to find. Oh, if we analyze this and we actually look at what's going on, we find things in existing data. The last one of these is just being a developer requiring SQL. Sometimes you see that it requires knowledge of some database like MongoDB and NoSQL. But somebody that has familiarity with the database, which means generally speaking, in that stack of things where you've got a user out here with a keyboard working on some app that talks through the frame cloud to a server, and it talks to a database, that your work is going to be right here at this level. You're going to be doing application development, quite often using an existing database, or an existing database that you're modifying, but you're in here doing this stuff. They probably have UI UX people for the front end and a graphic designer, and probably some QA going on all up here. But you're down here in the application development for the database. And you need to be able to build queries. You need to be able to do some tuning when they run slowly. And you need to know how to do application development, usually in some language. So Python is common with things like Bottle. We're going to use Bottle in this class. And Flask is another application thing. Go is quite common. But you have all of these different languages, but they're all going to require that you know how to be able to communicate to the database down here at the bottom. So programming, and you need a little bit of network knowledge. Chances are in this kind of a group, they actually have a network person. That is an IT person that understands the network. They've got somebody that understands how they're deploying these things. So you're not working alone, but you are working in this realm right there. And that is the most common thing that you're going to see where it requires some knowledge of database, is the application development, not as a sole person, but as a team. And a lot of startups, this is where they're at. A lot of small businesses. By small business, I mean less than 500 employees. For instance, I've done a number of things for Samsonite over the years. And they're a small business. Samsonite, they have got a DBA. They usually have a developer, but sometimes they're going to do a project. They need more in this category here. How they're going to get stuff done, or one of their people in their development team has left. And this could be any of a variety of things. You could have, in a manufacturing business like that, you could have stuff coming in off of the manufacturing that is being fed into a database over here with another system, and they're developing some application that they want to use internally that tells them how their manufacturing is going. Or an external application, or an interface to another company like their suppliers, where they're getting data from a supplier, but they need to be able to process that data and use it in their system. So, not necessarily are all of these like open systems to the internet like Amazon where you're doing retail, but there are a lot of pieces. When I worked at US West, they had 240 internal systems, roughly speaking, that were in this kind of a category. Everything from phone support to line support to planning for maintenance, and they're all feeding into different databases that they need a system that they can update and maintain and track these things. And you still see to this day people that don't have good tracking. I mean, my example of bad tracking where you go in and you go, oh wow, these people don't have inventory, US West. This is 20 years ago. They didn't have inventory that was real clear about their heavy equipment for doing line maintenance. And I went out to the yard where these people were checking out, front-end loaders and D9 Caterpillars that they're going to take out and do heavy construction work. And I asked the yard boss out there, okay, very level-headed guy, by the way, very level-headed guy. I asked him, so how do you know when you are low on, say, front-end loaders? And he's up in this building that's raised up above this big yard, and he says, well, I look outside, and if there ain't any, I just order some more. And I kind of thought that was pretty odd. And, this is a guy with a spittoon in the corner, and he chewed and had a big beard. And, Well, it's kind of gross, but he kind of leaked a little bit, and it came down both sides. That's how I knew he was level-headed, because, it was equal. And he'd launched one at the spittoon, and I said, well, do you track any of this stuff? He says, no, I just look outside. And I figured out that this was their database system at that point, and that, yes, there was no tracking going on at all. So sometimes you're building these things from the ground up. More often than not, there is a system, but it doesn't work right. But there are all of these kinds of data feeds going into databases. And this is growing dramatically, mostly due to information of things. And, it used to be that you might be some business that does air filters like cores, and they just change the filters every year. But those filters are very expensive, about $2 million a year in air filters. And if they're already used up, then it's actually dissolving the interior of your building with acid, so you're going to destroy your building over time, whereas if they're not used up, you're wasting money on filters. So you get an air pressure sensor. And the air pressure sensor now is feeding into a database over here that's telling you what the pressure drop is across the filters, because when the pressure drop gets too much, the filter is clogged, it needs to be replaced. So you build some stuff, you measure pressure, you get data over here over time. The data is telling you something important about running the business. And consequently, the amount of data in the world is growing bunches in everything you can think of. Wind turbines have data about the turbulence coming off the blades these days. And every one of these things, where does the data end up after it gets collected? Well, it's going in some sort of a database. And it has to have a model, and you got to build some user interface, so some processing, some statistics. How do you get rid of the data when it's outdated? All of these things. How do you do backups? What's the network communication? These are the kind of things that are being collected, that are ending up over here, that we're working with. And knowing some SQL, okay, you may think, well, I'm going to be working for this company, and they do X, and this doesn't have much to do with databases. Well, that's where the data ends up. So, real quick summary. Let's recap some of these things. If you want to be a database developer, this is a good class for it. Jobs like DBA are going to require probably that you get some more experience and you do some stuff for certification. They're really into, you're not wild and inexperienced, they want experience. But some certification will go a long ways for that. If you want to do things like full stack, I think you need to work on your curriculum vitae, your CV. And the project that we do in this class would be real good for that. We're going to build take a front-end application, we're going to attach to it a server, and that server, you're going to build some stuff in it, and the data model underneath. It has things like word search, which usually you only see out of tools like Elasticsearch. But there are a lot of commercial applications out there, like Jira, that do defect tracking, but don't have a good word search, don't have a good hierarchy search that are built into them. So you can talk about things like, this is why you built this, is you've got these other search capabilities. And that would come across well in some sort of a interview. Database jobs pay above average. That's always a good one. Quite a few of them you are going to be on call. So if that is not for you, don't do that kind of work. Today, most of these database jobs are remote. By my count, when I analyzed this, it came out to 92.8% or 92.2%. I think it's in the notes. Go look at it. But most of them are 100% remote. Which means if you're looking for a job where you can move to Pinedale, Wyoming, where it's not too expensive to live, and still continue to work, this is the one for you. And you're probably in this world going to need a good deal of familiarity with services that are offered at like Amazon Compute Services, and how to set up stuff on EC2, Extensive Compute Cloud, how to use Amazon S3 for doing backups, or the corresponding things from Google Compute Cloud, which I think is less expensive and provides more utility as far as I'm concerned. It's certainly easier to work with these days. Or something like Linode. And pretty much all the databases work better from what I have seen in my tests if you don't run them on Windows. And I know SQL Server is from Microsoft. They've even pointed SQL Server to run on Linux. It's not my favorite database for various reasons. And things like in SQL Server, there are 92 different formats for dates that are all numbered. It's 1 through 147 with some gaps with no particular rhyme or reason why, there's a difference between format 38 and 39. That doesn't tickle my fancy as a developer, having to look up every date format every time. And also, SQL Server has the ability to write statements where you can actually escape the database and run stuff at the privilege of the database itself. It's been a known security hole for 30 years, and they've never fixed it. And consequently, I don't particularly like that. MySQL is owned by Oracle. Oracle gives me, I'm willing to be an Oracle consultant, but it has its own set of challenges as Oracle is a business. So that's kind of MySQL and their Oracle database. But they're common and they pay well. So don't knock it and take too much. Okay? You can get training. Lots of people use it. It's very well established. If you're going to be a DBA, probably picking on being an Oracle DBA is probably one of the best choices. Or an IBM DB2 DBA, where you're going to be working for a bank. They're very stable, very high paying, very good jobs. So, you should be familiar with using Linux and the command line. For anybody that wants to see some of the power of the command line, MIT put together a course that is open source on YouTube called The Missing Course, I believe it is titled. But if you look for a Linux command line missing course MIT, Google that. It'll take you to the videos. It's 9-hour-long videos on using the command line on Linux, and you should be familiar with it because inevitably your database servers are not where you are. They are somewhere else, and you've got to be able to get to them across the network. And nice tools like pgadmin, they're really useful. I use them, and I also recognize that there are plenty of instances where they are really annoying because they're graphic, GUI tools, and they're not the right solution for doing maintenance. I want something I can script, that I can test, that can be reliably run day in and day out. Okay? Not something where I got to go in and click and cut and paste. Doesn't do it for me. I want to approach it as a DevOps problem and script it and test it and use it. So those things are really kind of critical. With that, I bid you farewell for today.